So anybody has any idea? What is a correlated subquery? It is a subquery that uses the values of the outer query. So in this case, the subquery is dependent on your outer query. In the previous case, right? In the case of a non-correlated subquery, as the name suggests, the subquery and the outer query was completely independent. There is no relation. Whereas in the case of correlated subquery, the subquery has to depend on your outer query. Okay, the correlated subqueries are dependent upon the outer query. For each row processed by the outer query, the correlated subquery is executed. It's very expensive. Okay, the result of the correlated subquery depends on the current row of the outer query. Okay, this is the the most expensive query or often less efficient. Look here, the correlated subqueries are less efficient compared to non-correlated because the subquery will get executed for each row in your outer query. That is the painful thing. So in this case, the outer query is this one, right? As outer. And the where class I have used is subquery. But in the subquery, select master column from table 1 where column 3 is equal to outer dot column 3 or something like that. Okay. So in that case, this subquery is completely depending on your outer query. Because here if you see, right, outer, this is the one, right, you are using it here. Okay, so ideally this one column 1. Okay, I just make it 1 here, not 3-1. Okay, so in this case, let's say in the outer query you have 1 million records. For each and every record, this query will get executed, because in the where class of this query you have used this outer queries column here. Right, the outer queries column is the outer dot column 1, right? Outer dot column 1, you have used it in your subquery, since this subquery is depending on your outer query. This is very expensive. If you have 1 million record here, or let's say 50 million records, for each record, this query has to get executed. Okay, the correlated subquery. Okay, the limitations of subquery. Now we will see what are the limitations here. The subquery. Okay, so what are the limitations of the subquery? Subquery will definitely impact your performance. Okay, it is complex. The complexity and readability also questionable here, right? So when you have multiple subqueries, a subquery inside a subquery inside a subquery inside a subquery, difficult to interpret, right? What is happening, in one go? It takes more time to understand. Especially if you use more number of subqueries, it can make your SQL statements more difficult to read and maintain. So the best practices you can, or the good idea is to break your very complex nested subqueries into CTs. You have something called common table expression or temporary tools to improve readability and sometimes even performance, right? So to overcome this issues, nesting limit, right? Nesting limit, the more the nested queries, right? And other limitation is the subqueries cannot be nested more than 32 levels deep. Subquery inside, subquery inside, subquery inside, subquery inside. If that reaches 32, beyond that you cannot use another subquery. So hence you have a limitation. Best thing, what to do, you break your logic into smaller thing. For example, first you find out the average salary of the employees, those live in the location something, and then that query you can use it to the other query, outer query. Okay, and with that you can find out the employees and this display the employees and salaries. Those are living in the specific location. Okay, break down the complex logic into some chunks. But remember one thing, most of the time the correlated subqueries are completely inefficient, because as I told you, for let's say in your outer query you have 50 million records are there, but your inner query, right, what will it get executed for each row of your outer query, because you are using the outer queries column in your subquery also. Okay, and limited reusability is also not that good. Okay, and Sometimes what you do is you can use joins. Instead of using the subquery, you can use joins to overcome the complexity also, okay? Now the question is the interview question. What is the difference between subquery and correlated subquery? That means they are asking you, what is the difference in non-correlated subquery and correlated subquery? What is the difference? The normal subquery, which is nothing but your non-correlated subquery is executed only once, whereas the correlated subquery is executed multi times for each row of your outer query. Next one is the inline view. So it is this, even the inline view is also subquery. So in this case, the query is used in your from class. See, ideally, I should have discussed a while back because in the practically when you work in a project, right, the customers, US customers, they say, inline view, can you please show me the inline view? Why did or explain the inline view that you have used it? Then you are not supposed to get confused. Followed by the from class, they've used the subquery. Okay, so that is called your inline view query. Okay, so in that case, what will happen is it will create a temporary table on the fly. So with that you can use it, in your main query. Okay, so those are the examples for the inline view, and next one is this one. What is that? Even the join clause also you can use the select query. Yes, you are correct. Okay. And next one is the in operator. Okay, what is in operator? Supposing you want to display all the employees who belongs to departments 1, 3, or 5. Okay, so in that case you can use simple in operator. With that you can query everything in one go. Okay, your query can return all the things in one go. Okay, you don't have to write multiple or condition. Okay, where depart number in operator is 10 comma 20 comma 30 something like that. Okay, so display all the, or you can say the depart number also. Supposing your manager wants to say, hey, I just want to see depart number 10, 20, or another example, region. Okay, where region in north region, southeast region, west region. Okay, you can put multiple literals here. What will happen? The outer query will check each and everything. Okay, depart number in 10, return all the employees and their corresponding depart number. And again, it goes to second condition. Okay, the where depart number equal 20, return all the employees and depart number for the depart number 20 and 30 as well. So you have understood what is in operator here. Okay, and we have something else called exist operator. Exist operator, I already discussed with you people. The exist operator, we use it to perform the existence check. Basically a logical operator. They exist a logical operator. So it checks whether a subquery returns any row. Okay, at least the subquery should return one row. Okay, so the exist operator, what it does is, right behind the scene, it returns true if the subquery returns one or more rows. If the subquery does not return any rows, then it will return false. Okay. For example, let's use some query. For example, I want to check select e-name from depart number, and here, okay, and from employee, and here what I do is I'll use directly the where clause and then exists, and then where exist, and here I'm going to use select star from employee where salary is greater than I think I don't remember what the salary. I just give something like 3,500. So whether right, okay, what I will do is I'll just execute this query and see first if that returns any records. Yes, 1% salary is only one person who is drawing the salary more than 3,500. So basically, we want to dynamically check, right? So I just want to execute this one. Look here, in this case, this one returns true, okay? This one returns true, and it gives me all the things, okay? Here, basically what we are trying to do is, right, select the employee name and depart number where salary is greater than 3,500, okay? No, this is not employee name. Okay, let me do one thing. Or salary, we'll use salary here. This is what your question, right? Preeti, okay, our question, in a second, I'll just check. And here, this is a little bit different, okay? So don't think, the salary is employee where salary is greater than 3,500. No, 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 not like that, okay? Here, we are not checking, display all the employees whose salary is greater than 3,500. It is not like that. Basically, we want to return all the employees and salary. Where exists salary is greater than 3,000. That means, at least this subquery should have only one value. Okay. If this subquery returns one value, the outer query will get executed. That is the idea here. Okay. Don't confused. Don't get confused. Here where salary is greater than 3,000. No, no, no. It is not where salary is greater than 500. Here basically the exists operator, will return. If this subquery returns a record, right? It simply return true. That's all. So what we will do is basically, right, in the department number, ideally here we are supposed to select depart number. We select star from depart. Okay, and where depart number is equivalent to depart number is equivalent to 30 or something like that. Okay. First, we will check. Basically, you can try your, something. Don't write the complex queries, Atlanta, right? Sales department is in Atlanta. And here I just say, I'll just check. Okay, return. For example, here, I just say, right, so 130. This query, the subquery will return false. This one will return false. Hence, the outer query will not get executed. Okay, only if the department exists, right? Any specific department exists, you can execute the outer query. So the exist operator performs an existence check whether the subquery has any record in it or not. If only if the depart number, the specified depart number is there, then you can. Otherwise, don't execute. See, executing. See, you just think the outer query returns 5 million records. What you are conducting some basic search. First of all, if the customer number is present in our customer table, if the customer number is present in the customer, then execute the outer query. Otherwise, don't execute the query. It will save a lot of time, isn't it? That is the whole idea of exist operator. And next one is the set operators, union and intersect, and union and intersect, all the things we discussed, right? We discussed as part of Power BI itself. Okay, what is union? Any of the union also I will show you in DAX in the upcoming weekend. Okay. So the set operators, the union, intersect, and minus. Here we don't have minus, but instead we have except queries, and we have union all is also there. In the interview, they'll ask you what is the difference between union and union all. So union all for example, I have two tables A and B. All the records from both the tables will get joined together, combined together in the case of union all. But while combining it, in case of any duplicate records are there in both the table, table A and B, it will blindly combine the data from both the tables. That is what union all. Whereas in the case of union, it combines both the tables data. While combining it in case of any duplicate records, it will eliminate it. Okay. So what are the guidelines for union? Okay, the guideline for the union is one second. Okay, the guideline for the column alias must be expressed in the first query. You have to specify the column alias and number of columns. Let's say in the first query you are using 3 columns and second query you are using 4 columns. It will not work. Okay, it will throw in, and the data type must be compatible for implicit conversion. Okay, next one is the intersect. intersect, this something like this. Okay, country, region, city. Look here, country, region. This is one column, and city is another. Two columns are there. Instead of intersect, you can use union. Okay, but whenever you use union or intersect, make sure that the number of columns that you use it in your tables should be same. So number of columns and column name should also be same. So that is what the guideline says here. The same guideline is applicable to intersect also. As you can see in this image, if you want to take the intersect between these two, the common values are 2, 3, 2, 3, 2, 3 will be written. That's all, guys. What does it, right? So these are the example for the intersect. And in place of intersect, you can use the union also, and then put union all. Union will not return duplicate values while combining the data from the two data sets, whereas the union all will combine all the values. For example, 1, 2, 3 is there, 1, 2, 3, 2, 3, 4, it will have it, union all, okay? Whereas union, it will not, it will use its, in common sense, okay? So 2, 3 is there, again 2, 3, why should I, you can knock out this, and 1, 2, 3, 4 will be there in the case of union. Union will eliminate the duplicate. Union all will not remove the duplicates while combining the data. Intersect will show display only the common value between the two data set. Okay. Now the $1,000,000 question is, what is the difference between the intersect and inner joins? What is the difference between intersect and inner joins? This is a little bit tricky, and people will get confused here. Intersect, it returns the distinct rows, right, that are common between two data sets. Okay. Whereas the inner join, what it does is it combines the rows from two tables based on the common columns. Only when you have the common columns, it will, return the records. And you can, first of all, you can combine the data from two tables based on the common column. Otherwise, it will not do that. Whereas in the case of intersect, it simply returns the common values between two data sets. Okay. Next one is the except returns only the distinct rows that appear in the first set but not the second. Okay. So here something like A minus B. Okay. For example, here you have 1, 2, 3. Here you have 1, 2, 3, but here you have something like 1, 2, 3, 4. So 1, 2, 3. 1, 2, 3 is there, which is not there in the second one. Sorry, whatever is not right. The 4. The 1, 2, 3 is there. Oh, sorry. Okay, here you have 1, 2, 3. Here you have, let's 2, 3, 4, 5. Okay, so what it does is 1, 3, 4. Whatever you have it in the first table, the same data that you have it, that one you display it here. Okay, that is the one it will give you. Basically, you don't have any minus operator here. Okay, next one is the inner join, left outer join, right outer, full outer join, self join, and Cartesian join. We have already discussed the inner join, left outer join, right outer join, all these things, including the semi left anti-join, right anti-join, as part of the Power Query editor. The same logic here also, applicable here. I'll share the script. Okay, you can practice it. Okay, not much difference. Okay, you need to use inner join. I'll just show you one example for the inner join. Once I show that one, you can use the same thing for the other one. Look here, I just go here. I just say select listen e dot listen. I'm going to give some alias here because okay, I just use from employee inner join department D, and here I'm going to use on. Okay, so on e dot depart number, and then I just say D dot depart. I'll explain it, don't worry. Okay, here I put employee ID. Okay, e dot name comma e dot salary. Inner join. Okay, what is inner join? What is inner join? We already discussed as part of the um, Power Query Editor. Emp number, I think so. Yeah, emp number, right? Yeah. Emp number, e-name, salary. Okay. Here it is doing the inner join. So whatever the department, depart numbers that are there in your department table, the corresponding records fetch it from your employee table. That is what is happening. Okay. So ideally, what we do is here d dot d name along with the instead of employee number e name, I'm going to use it. Display the employee name along with the department name, because these two columns are available in two different tables. To select the data from more than one table, you need to join the tables. In order to join the tables, you need to use the common column exists between the two tables. Look here, the employee table, we have depart number. What is E? E is, short name for employee, alias, okay? And depart, for this, the alias is D. And in, both the table, these two columns are available. These two different tables, right? Employee and department table, we have employee name and D name is available. Hence, we need to join the employee and department table. Here, I have used the inner join. And also without fail, you need to make sure that this your joining condition, okay, where the e dot depart number, d dot depart number, right? So you need to query this one. So why do we need to use inner join first of all here? Because the employee name and d name is available, department name is two different tables. Hence you need to join. Either you can use inner join or left join or right join or outer join, all the things you can give it a try. Replace the inner join by with the left join and right join, outer join, all the things you can try it, right? All the things you can try it out. Cartesian join is something like, it is a very, very expensive one. Which one? The Cartesian join. It'll, it'll join each and every values from your first table to every other row in your second table. That is what your Cartesian join. Correct? Yeah. 1 second here. Somebody is calling. Okay. So here you can use the left join. You can use the right join, outer join. Okay. Outer join is a full join. Okay. The Cartesian join, how it works is, for example, you have table A and table B. You have 1, 2, 3 is there. Here you have 1, 2, 3, 4, 5. Right here you have just 1, 2. This value, every row from your first table will get joined with every other row from your other table. And similarly, this is the one. This is very, very expensive operation. Okay, if you, even in this case, if you don't use this one, right, the common column between the two tables, employee and department, it will do the Cartesian join. Okay, every row in your table will get joined with every other row in your the other table. That is what your Cartesian table. Next one is the self join. Self join is joining the data from a same table. Okay, sometimes the key columns will be available on the same table. Okay, so in that kind of situation, you may have to use the self join. Okay, you don't have to join more than one table. That is what I'm trying to say. Look here, in this case, select star from employee. In this case, if you see employee number and manager, both of them having the employee number only. So here the 7369 is the employee number for the Smith, and whose reporting man is 7902. Look here, 7902, where it is, this one, right? Ford. The employee ID 7902 is nothing but Ford. This guy Smith is reporting to Ford. That means Smith's manager is Ford. Okay, and who is the manager for Ford? 7566. Who is 7566? Jones. He is the manager. So in that case, let's say your manager wants you to create a report wherein it should display the employee name and their corresponding manager name in a single query. How can you do that? Okay, how do you do that one? This is, I will, leave it with you. You do some Googling and then you practice it, okay, and then I just give you a clue here. So in this case, what you need to do is you need to use two different alias for the same table. Okay, two different alias for the same table, because we are not joining more than one table. You are doing the self join. Okay, you are joining the self join. So you give the employee table as an alias C, something like that, and you give the same employee table with different alias like M. So what you need to join these two different tables or different aliases. Sorry, not the different tables, same table with different alias name. Join these two different aliases. Using the employee number is equivalent to MGR. Okay, and then order by your manager or something like that. Okay, so that way you can do the self join. Give it a try. This is an assignment for you. Okay. Self join is joining a table to itself. That is called your self join. Got it? Okay, we are done with all the different types of